this question, we want to talk about parametric parabola. Question says graph and analyze parametric equations below. X is equal to 2t minus 1 and y is equal to a half t plus 1. So let us use a table, t, x, and y. If t is equal to -4, x becomes -1 and y is -1. So when t is -4, -4 times 2 is -8, minus 1 gives you -9. And when t is equal to -4, here a half times -4 becomes -2 plus 1, which is -1. With the same calculation, we can plug in different values for t and find the values for x and y. So when t is equal to -4, you have this point in xy plane. When t is equal to -2, you have -5 and 0. This is your second point on this curve. When t is equal to 0, you get -1 and 1. This is the third point on your graph. And then if you plug in 2, as you can see, I'm using the values to make this simpler so I can get rid of this denominator. You have another point on the curve. And finally, let us take a look at another t value, which is 4. And my x becomes 7, my y becomes 3, simply by just plugging these values here. And this is the last point here on my curve. When I connect this together, I see an increasing line. You could also get rid of your t. Since x is equal to 2t minus 1, 2t becomes x plus 1, or t is equal to x divided by 2 plus a half. Very good. So your y, which is a half times t plus 1, becomes a half times a half x plus a half. When you distribute a half into parentheses, it becomes a fourth x plus a fourth plus 1. Now, if you take common denominator between these two values, it is 5 divided by 4. So we found the equation of the line with positive slope. So we expect the line to be an increasing line with y-intercept 5 divided by 4. Another example for you. Here we have x to be sine t and y to be 1 minus cosine t. And t is bounded between 0 and 2 pi. So let us form our table, t, x, and y. You can plug in different values for your t based on the given interval. When t is equal to 0, of course, sine of 0 is 0, and cosine of 0 is 1, so 1 minus 1 becomes 0. Now, when t is equal to pi over 2, sine of pi over 2 is 1, and 1 minus 0 becomes 1. With the same argument, just plug in different values for your t and find x and y. 3 pi over 2, x, which is sine of 3 pi over 2, is -1, and then cosine of 3 pi over 2, which is 0, 1 minus 0 becomes 1. And then finally, let's plug in 2 pi, which is the terminal value. You get 0 and 0. This is the graph of your curve. This is a circle centered at 0 and 1. And as you can see, this is not centered at the origin. When x is equal to sine of t and y is equal to 1 minus cosine t, or y is, if you bring 1 to the other side, y minus 1 becomes negative cosine t. X squared plus y minus 1 to the second power is sine squared plus cosine squared, which we all know it's equal to 1. So here you have equation of a circle with centered at 0 and 1, and the radius is equal to 1 as well. In this question, we want to eliminate the parameter to find a Cartesian equation. Your x is equal to square root of t plus 1, and y is equal to square root of t minus 1. So since x is equal to square root of t plus 1, raise both sides to the second power, x squared becomes t plus 1, so t is x squared minus 1. So wherever you see t, you can use x squared minus 1 here. So your y becomes square root of x squared minus 1, or you have square root of x squared minus 2. Okay, this curve is part of the hyperbola x squared minus y squared equals to 2 when x is more than square root of 2 and y is more than or equal to 0. So by getting rid of the parameter, we can find a relation between x and y, and in this case, you have a hyperbola. You can visualize this as well. So this is just part of the hyperbola. Be careful about the domain. T minus 1 must be more than or equal to 0, and t plus 1 must be more than or equal to 0 because you have square root. And then when you look at x squared minus 2, it must be more than or equal to 0 because it is inside the radical. Next question, you want to eliminate the parameter to find the Cartesian equation. Your x is equal to hyperbolic sine and y is equal to hyperbolic cosine. Remember the definition of hyperbolic sine of x. Hyperbolic sine of x is nothing but e to the x minus e to power minus x divided by 2. And hyperbolic cosine of x is nothing but e to the x plus e to power minus x divided by 2. So these are the definition of hyperbolic functions. Now, since x is equal to hyperbolic sine of t and y is hyperbolic cosine of t, as you remember, y squared minus x squared, or hyperbolic cosine squared minus hyperbolic sine squared is always 1. So since y is equal to hyperbolic cosine of t, from what we learned from pre-calculus or elementary calculus, hyperbolic cosine of t is more than or equal to 1. We have the upper branch of hyperbola. And one last example for you. Eliminate the parameter to find a Cartesian equation as follows. X is tangent squared of theta and y is secant of theta. Your theta is bounded between negative pi over 2 and pi over 2. Remember that 1 plus tangent squared is equal to secant squared. So 1 plus x is equal to y squared, or x is equal to y squared minus 1. So this formula is coming from your pre-calculus, everybody. So you need to review pre-calculus. Tangent squared is equal to x. So wherever we see tangent squared, we just write down x. X doesn't have any exponent like 2 or 3. It's just x itself. On the right-hand side, secant squared is y squared. So that's how you end up with y squared on the right-hand side. Well, what do we have here? We have just this portion of the graph. Why is that? Because our theta is bounded between negative pi over 2 and pi over 2.